Hello, everyone. My name is Al Patel. I'm the application engineer with LaMarche Manufacturing. Thank you, everyone, for joining our first of 3 Charging Ahead Beyond LED webinars. All 3 technologies have been widely used over the years and have field-proven track record as a battery storage solution. The lead acid and NiCad chemistries that we are all used to have served our storage needs for decades. However, today we've all become more familiar with new and emerging technologies with many benefits and advantages. The first webinar will introduce you to FZSoNick's sodium metal chloride, the second SAS lithium ion, and finally LaMarche's hybrid supercapacitor modules. During the webinars, we will discuss the technologies, benefits, and applications, along with what LaMarche has to offer for optimal charging solutions. Today, we have Andrew Morelli with FZSoNick to go over the sodium metal chloride battery. After battery portion, we will go over the A77 charging solution and why it's the preferred charger to charge sodium batteries. Finally, we will end up with a question and answer session. I hope today's webinar will provide a more in-depth knowledge of the emerging technology advances in battery backup solutions. Thank you, Andrew, for joining us today. And if you can start your sharing your presentation on the FZSoNick sodium metachloride, I'd appreciate it.
Absolutely. Welcome, everyone. My name is Andrew Moraldi, and I will be presenting on the sodium nickel chloride battery. Hopefully you guys can see my screen. So as I said, brief introductions. The 3 of us are on the call today. I'll just quickly introduce us. I'm Andrew Moraldi. I'm the applications manager for the sodium nickel chloride products here in the Americas. We also have Miss Kara Hagen, and she's the general manager based in Atlanta. And then we have one of our sales managers too that's on the line, Patrick Russell, and he's based in the Dallas, Texas area. So we'll do just a quick overview of our company. We are part of, and we were originally part of the FIAM group. And some of you may be familiar with FIAM batteries. We have since moved away from that name because that portion of the company was acquired by Hitachi Chemical, and the FIAM branding went along with it. So we are now known as FZSoNick, and we've been around, as you can see, for almost 100 years. But in 2011, we acquired the 100% of the technology, and we've been producing this technology now for over 20 years. Here's our footprint in the world. Our headquarters is in Vicenza, Italy, and our manufacturing center is in Stabio, Switzerland, which is just north of the Italian border on the western side of the country. We also have service centers around the world, and we produce service centers, or we build service centers as close to the product, main use centers that we have. So we have our headquarters in the U.S. is in Elgin, Illinois, not too far from the LaMarche facility. And then we also have a manufacturing and service center in China that manufactures just for the Asian market. The main characteristics of our battery system is our number one. The battery is absolutely immune to ambient temperature. From -40 to +60 C is our specified temperature range, but our batteries will operate even in higher temperatures than that without detrimental effect. This immunity is not only for the life cycle of the battery, or the service life of the battery, but also for performance. There's absolutely no effect on performance or service life over the extremely wide temperature range of -40 to +60. This battery can also be used in cycling applications. We have very, very good cycling characteristics. 4,500 cycles is obtainable within the service life of the battery. As I said, the battery has a very long life because there's no degradation of the battery based on time or environmental conditions. So high energy density and long service life. And strangely, we found that in applications where lead acid battery theft is quite rampant, our product has a theft deterrence in it because it just doesn't look like a battery, and there's really no valuable recyclable materials, even though it's 100% recyclable. So safety, we are the safest technology that is available today. We will never produce any gases in an operation or even in worst case failure modes. There's no flammable materials. The battery is basically made out of stainless steel, ceramic, and salt. There's no flood or fire water damage, and we have extensive testing, and not only in labs but in the field as well. So. And our battery is made out of a very robust material, heavy stainless steel. So it's actually a very physically robust design. So in terms of the impact and environmentally and on the world, we don't use any dangerous materials in it. There's none of the materials in the battery are toxic. And so it has no conflict materials or materials that have been known to be highly polluting, so such as cobalt. So we compare our batteries to most other technologies out there, and this is a comparison chart between lead acid, NiCad, lithium ion, and our product. As you can see, our product can be installed directly outdoors without any, special enclosures. In fact, in some of our products, we mount them right to the bottom of the train. They're IP65, and so they're exposed to the outside environment. There's absolutely no risk of fire or explosion with the products. You don't need any special fire suppression equipment. Room ventilation is not required. Air conditioning is not required if your equipment doesn't need it. And there's no maintenance on these batteries. There's really nothing you can do to these batteries other than monitor them to tell you if they're okay. And then in many cases in our 48-volt product, we can have single module redundancy. So single modules can have multi-string capabilities internally. This is a quick technical overview of our product. We only produce one cell. It's 2.5 volts, and we use that cell as our technology blade and our building block to produce modules. And the modules are the bus voltage of the application that we're targeting. So we never connect our modules in series. We only connect them in parallel to increase capacity, and we have bus voltage levels for the most common bus voltages used throughout the industry. Our battery is active materials are very, very simple. It's table salt and nickel. And as you can see from the little chemical equation up in the top right-hand corner there, that we start out with common table salt and nickel, and then when we charge them, we chlorinate the nickel and separate the metallic sodium. And you can see from the cutaway portion of the cell the various components that we use inside of our cell. So I should mention, and it was in the thing, that all of our batteries run at an elevated temperature. Our nominal temperature internally is 265 degrees C, and we design the batteries and the insulation systems such as that the outside of the battery case will always be within 10 degrees C of the environment. So each one of our batteries is married to a battery management system. It's installed at the factory and is not user serviceable. So that is the interface between the customer and the world, or the battery and the world, excuse me. that device manages all the internal temperature management, and it also manages all the optimization for charge. So in this particular case, you just need a nice clean DC voltage, which is provided by the charging equipment, in this case the LaMarche charging equipment. The BMS is also one of the keys to our safety of our product, because it eliminates the potential user contacts of high energy components and terminals. And it also provides protection against short circuit and electrical abuse. Finally, it will allow remote connection, so you can the battery can be monitored in real time, and the capacity determined in real time at any time. So the processes and materials that we use in our battery are listed here. So the main assembly functions, or main manufacturing function we do, is making the ceramic tube, and that ceramic tube is the separator between the anode and cathode, and that's really where our technology and our manufacturing technology comes from. Three-quarters of our manufacturing space and equipment are dedicated to making that tube. Once we get the cell made, then assembling the battery is pretty standard manufacturing process. I mean, we're putting stuff in a metal box and connecting it to electronics. The battery has, as I mentioned before, the battery has very low environmental impact. It's 100% recyclable. We use all of the materials in various processes around the world that are useful. The one reality is that we don't recycle many of these batteries, because since they don't degrade over time, when they fail, they're not bad, they're broken, and something that's broken can be repaired. So in many cases, a battery that has failed can be repaired and returned to service by replacing some of the cells or the electronics, if that happen to be the point of failure. Let's start to talk about some of our applications now. In the 125 volt range, we've been eliminating, and this is where we see a lot of the A77 use, is we've been eliminating the lead acid batteries, which are generally 60 cell strings, or in this case 20 jars of 3 cells per jar. We can generally do that with one of our modules, which the text is a little small on this one, so you can't really see the dimensions, but it's about 24 inches by 24 inches, and it's approximately 12 or 13 inches tall. So with 160 amp hours, we can generally replace just about most of the smaller switchgear strings that are produced with a zero maintenance battery that you can eliminate spill containment, eye wash, hydrogen detection, and of course quarterly maintenance or watering. So some of the other applications that we do obviously are very, very similar. We can reduce the footprint of the energy storage, in some cases by very high percentages. Likewise at the 48 volt level as well. We've also have a very high density improvement for nickel cadmium in many cases in the telecom or substation market at 48 volts. We're some cases we're 3 times the energy density. We also use the battery in lead acid replacements, and one of the unique characteristics of the battery, since it does not have a specific float voltage, it has a very wide float voltage range, we can be paralleled with existing lead acid technologies. In this case, it was done as they were mining out the lead acid batteries, and the sodium batteries save so much space, they were able to install them in kind of some free space in the room while they reclaimed the rest of the room and disconnected the batteries in a hot swap type technique. This slide is a comparison of various technologies In terms of the amount of floor space and the amount of service aisle they generally require. And because of our 48 volt rack system allows for the service aisle to be on the short edge of the product, we can reduce the amount of space that's needed both for the energy storage and what it would take to potentially service or install the batteries. Here's another slide that we used to show a comparison of the various technologies in comparison to our battery. And as you can see, we in general we get our density by going vertical, and in some cases we do tell customers that even though we're more dense, in some cases we can be slightly higher floor loading because our floor dimensions are much smaller. As far as testing and certifications, the product has been extensively tested based on not only based on industry requirements, but new fire codes and building code requirements. And so in the telecom world, of course, we comply to the Telcordia standards and have been tested to the NEBS 3 level. In all of our products are UL 1973 and will be covered in our 9540A reporting, which is the large-scale fire testing that UL does. It's become a kind of a de facto standard for most emerging technologies, and including even, I mean, not even all emerging technologies, but even including lead-acid batteries now. And also, since we're a European company, we comply to most IEC and European standards as well. And we have detailed reports from third-party labs that have been doing research on our batteries for years now. So whether it be NREL or Pacific National Labs or some of the universities up in Canada. So we're very well known in terms of the testing and qualification and certification of our battery. This is our product range. Basically, we make products for all secondary battery that are large format applications. We started out making batteries for the mobility world, so mainly we stick to service vehicles, buses or trucks, and we as well as mining equipment and stuff like that. And then obviously the industrial, we have telecom and the switchgear market. And then obviously we go as big as energy storage, which is just large containers of our batteries. So as far as our installation base, we've been manufacturing the product for for almost 20 years now, or over 20 years technically, since 1999, and we have probably closer to 5 megawatts installed now easily. So and I would say that these charts are starting to get a little old. Our customer base, we have a very wide customer base, as you can see here. And then finally some more installations, the mobile telephone switching centers, the railroad market and the switchgear market are really the markets that we've concentrated here in the US. And then there's our contact information, so we can share this presentation with the group if we'd like. So, Al, I can hand it back to you now.
All right, thank you, Andrew. As we all saw, there's a lot of performance and safety related advantages going with the sodium chloride from FZSoNick, along with the no impact to the environment compared to the other technologies we're used to. Now what we'll do is we'll talk a little bit about the A77 and the advantages by using an A77 over any other charger that's available in the marketplace. First of all, it's FZSoNick qualified. Andrew, along with our engineering staff, had qualified using the A77 to charge the sodium metal chloride battery. They performed complete charge and discharge cycles to make sure it was a viable solution. Available in 24, 48, and 130 volt, 260 volt systems. The A77 has them charging output voltages and is available, and FZSoNick has a battery solution for that. A77 smart charger, basically, it's just a typical constant voltage charger. Here's a kind of a one line of what system looks like when you have the sodium battery and the charger connected basically to a distribution center and to your loads. The performance advantages, field proven microprocessor control technology, which makes it unbeatable when it comes to response time, and the complete PID control that was written by our engineering staff here at LaMarche. Unmatched load regulation for charging sodium batteries. The load regulation on A77 outperforms any other charger that's out in the market right now. The fastest transient response, because of the inherent design and technologies of sodium battery, a charger would need very high fast transient response to perform and charge that battery properly. Sizing the A77 and configuring it. Basically, at the moment, with the different types of applications that the sodium is being used in at this moment, with the utility and some of the offshore refineries and just general industrial applications, what we require is to, if you can provide us with the system load profile, we will work with the engineers at FZSoNick, get it sized, and get you a quotation for that, along with the charger. When ordering a A77 charger, basically, instead of using a typical lead acid or NiCad suffix at the end, we have created a new one called SOD, basically stands for sodium battery. No, you don't need number of cells, are not required because it's a complete package, as you saw in some of the pictures that Andrew had presented. And the nice thing is that it comes factory set from the factory at 130 volt DC. Currently, we are working on some software updates that will make the installation much faster, where the automatic float voltage will be preset already. And since there is no need to equalize the batteries, we are going to inhibit the equalizer charge cycle. With these advantages, you also get all the other advantages with the LaMarche A77. You get the full 5-year warranty, the UL compliance. There's all different models ranging from 10 amps all the way up to 500 amps that's available. So definitely A77 is the preferred choice when charging sodium nickel batteries. I think I'm going to open up now to any questions that anyone may have.
Um, yeah, Andrew, this is Rick Chambers Industrial. So are they considering that a float only voltage, and what is that at?
I mean, our basically the float voltage just needs to be, or the charge voltage just needs to be above the state of charge of the cells. They can operate in partial states of charge just fine. So we really don't have a specific float voltage. It just needs to be above the fully charged voltage of the cell to get 100% state of charge. If it's low, the batteries it'll be like your seatbelt buzzer. It'll complain to you that there's not enough bus power, but it'll still be able to provide whatever energy is in the battery and will not degrade because of that lower voltage control. So, I mean, even if the charger does, lose its, capability to regulate properly, in most cases, it won't damage the battery.
Yeah, well, I guess I was asking, like, if you're at 27 now, say on something else, I mean, where would that charger be set?
And so
On
you're talking
20
about on a 24 volt string?
on 24 volts,
Yeah, on
yes.
24 volt string, we basically, that's a 10 cell product for us. So would be 2.67 times 10, which is pretty easy math. So as long as we're above 26.7 volts, you'll get 100% charge.
Okay, Okay, thanks.
Yeah, I felt like on our 48-volt product, just because it's stuck in my head because I've been a telecom guy my whole life. That in general, we tell the customers just pick a round number above 53.5. So
Right.
many of them just set it to 55 because it's just an easier number to remember. So
Okay, as far as accepting recharging, is
mhm.
it faster than lead or AGM or?
Our fastest recharge rate is 12 hours from 0%
Okay,
the charge. In general, when we design systems, or and because of the granularity of our modules, most cases, most applications are not are only designed to go around 80% depth of discharge. Not that you can use all 100% of the sodium battery. It's just most engineers are conservative, put a 20% margin in.
okay,
And if you do that from 80% charge instead of 12 hours, it's closer to about 10.
okay, okay. Is there damage if you go too low on this discharge?
No, no. I mean, the BMS will always protect the battery, so it'll discharge until it's out of energy, or the two end of discharge. Characteristics of this battery is it's either out of energy, it's at 0% state of charge, or at high rates. And I see one of the questions in the chat is will it support high rate applications like UPSs? And we do high rate UPS, but we don't get into that anything below like a half an hour.
Okay,
So yeah, and that's just because this other characteristics, when we discharge at higher rates, then we kind of optimize the batteries for the 4 to 6 hour to 3 to 6 hour rate, in terms of the thermal management portion of the battery. But when we discharge at very high rates, the internal temperature of the battery reaches our upper maximum before we've delivered all the energy.
okay,
So we can do high rate applications, but we generally have to oversize.
okay. Thank you.
This technology's been around since 1938. Why is it not more popular? Is it the price point on it?
Well, I mean, one of our cons, and one of the reasons that the automotive industry kind of moved away from trying to use our product is because of cost. So we are, in general, we are more expensive than the lead acid products, and when you well-designed lithium product that's been UL listed and tested, is generally going to be much closer to the cost of our product. But the manufacturing cost of that lithium battery are way lower. And truthfully, the real reason is that we're absolutely horrible at marketing. Yeah. I mean, our general manager would absolutely agree with us. And we like to say that we don't have any really bad YouTube videos of our products, so nobody knows about us.
Is there competition, other manufacturers? It seems like this might be a proprietary process.
We are. We're patent technique, but it's been about 10 years, maybe a little less now. GE, we were partners with GE, and we partnered with them to do hybrid locomotives. And it wasn't long after they got in bed with them that they decided that they were going to make their own product. They changed the shape of our separator a little bit to get around our patents. But they closed. They basically got out of the industry, about 7 or 8 years ago because they just couldn't compete with us. Every time, we've had so much more experience with the product that when we would compete against them head to head, our product performed better every single time, even though it was exactly the same design.
Yeah,
The other thing, Rick, I'd just like to chime in is that, when we came to market in the US, we've been commercially producing the battery since 2000. From 2000 to about 2011, it was really for electric vehicles. That was the CEO at the time, and the owner of the company had a passion for converting vehicles to electric. And then in 2011, we came into the US market in telecom. We are now just entering the industrial market, and while pricing is really tough in telecom for us because we're normally competing against, 12-volt jars or 2-volt cells in a string of 48 in the 125-volt industrial market. that pricing challenge that we had has seemed to go away quite a bit, especially with all of the benefits.
Yeah, I just want to bring up one thing. I know Andrew did mention that there's a BMS on the sodium battery. The nice thing is that there is no special communication required, and the LaMarche charger will charge that battery without any issues.
Absolutely. Yeah, I mean, there is communications available, but it's not required. It's for there's no intelligence needs to pass between the charging equipment and the battery for it to operate properly. So a couple other questions I see in the chat are, yes, the Elgin facility is our U.S. repair facility. That's where we do all the repairs on the batteries that are used in the market in the U.S. here. And then the vertical profile, yeah, of course it affects the seismic rating, but we're seismically rated to 8 shelves high on this product. So we get all of our high density racks are seismically rated. So we don't have any issue with the seismic rating at that 8 high level.
Great. I know Rich Hutchins had made a good point here in the chat. He mentioned that when the air conditioner on a typical VRLA battery system installation fails, so do the batteries. In a short time period after that, the FZSoNick won't have any issues because there is no air conditioning required on that.
Yeah, I didn't really touch on it too much, but our product has an indefinite shelf life and indefinite storage life. So even if the batteries are left in the field for long periods of time without any connection to a charger, they're not going to be damaged by long-term storage or conditions. We actually have a white paper that, and I think I shared it with the LaMarche folks, is that we had tested a battery that sat in storage for 14 years in an outside environment, just stored in its wooden crate. And after 14 years, the battery still tested at over 99%.
Liquid sodium is a nasty material.
Absolutely.
What sort of I assume shipping and consideration on this all get categorized under a hazardous label.
Yeah, we have a UNB on shipping code that's, the hazard is dangerous when wet. So we do still have to ship under hazmat, but in reality that's based on the materials and not the fact that it's an article. It is literally impossible to get metallic sodium out of the battery. Number one, it won't freely flow. It's only liquid when it's above 150 degrees C. And number two, in our one of our safety characteristics, and I didn't get too deep into the technical side, but one of our safety characteristics of the battery is when the active materials meet, they produce stable solids, and it's table salt and aluminum, right? So even in severe mechanical damage, the metallic sodium wants to be salt and wants to react with the active materials, the liquid electrolyte, at a 16 times higher rate than it wants to try and decompose the atmosphere. So it's very difficult to get metallic sodium out of these batteries, even if they're severely mechanically damaged. So since we use these things in vehicles above the 3-meter height, we have to drop them from 3 times that, so 10 meters, onto every single type of crash barrier that is known. And we don't even get metallic sodium out of there when we basically taco the pack. It bends it in half. So yeah, we also do penetration test. I mean, of course, UL has their nail penetration test, but we take that to a much bigger extreme. We penetrate the battery with about a 4-inch pyramid-shaped ram, 3/4 of the way into a 620 volt pack, and then we pump water into it to show that you really don't even water reaction with the battery is not a dangerous situation.
What is the electrolyte in the battery?
So the main electrolyte is the beta alumina separator. And so that's our
Oh,
that's our
okay.
solid state step separator. But absorbed in the porous structure of the sintered nickel and the ceramic is a liquid electrolyte, which is tetraaluminum chlorinate. No. And that represents a very small, like 1.4% of the whole mass of the battery. It's a very, very small amount, but it does aid in the fast transport of the sodium ions and supports our reaction efficiency. It's, most chemical reactions are very, very dirty, and our reaction is very clean and very efficient. In fact,
So it's really a solid state battery, so to speak.
we kind of bridge that line. The definition of a solid state battery isn't really kind of loose right now, but we do kind of feel that we fit that definition.
Thank you.
Jeff England with Electrorep in Kansas City. Again, going back to the relative price points of a 125 volt system, let's say a 160 amp hour system, differences between lead acid and NiCad and your technology, just rough ballpark differences.
Kara, you want to answer that one, or Pat?
I mean, I can make some comments without giving some direct pricing, but I mean, you got to look at everything because it depends. Like nickel cadmium, in those environments, we found when we're pricing against them in industrial, we're actually pretty competitive. We haven't had any customers in industrial like we have in telecom. I go, gosh, that's so expensive. On the industrial side, it seems to be almost on par with nickel cadmium. Patrick, do you have any color to add with feedback from customers on the pricing on industrial side?
Yeah, I mean, I can talk to it from oil and gas point of view, where we're working with a large producer out of Baton Rouge, Louisiana, at one of their largest refineries, and we're replacing, like I think Andrew had a picture of it. We're moving out all of the lead acid, and putting in one of our 125 UP series batteries to replace all of those jars. And with that being said, there's no spill containment, there's no air conditioning, none of that's in there. And this particular large producer found it very easy to get an ROI out of it because there's no maintenance and they don't have to send crews in there any longer where they'd have to do it monthly. That all goes away, and if you put a price tag on that, it's huge. So you consider, like Carl was saying, the entire program of replacing it, get rid of the maintenance, get rid of the safety issues, all of those kind of things. It's very, very affordable in those applications.
What do you show as, or do you publish a projected life? Typically, lead acid is going to be 15 to 20 years. NiCad's going to be in the range of 25 years. Do you just say indefinite, or what?
We have an engineering life and a service life that is 20 years, and that's or 4,500 cycles, right? So, and basically that's one cycle a day for 11 or 12 years. So if it's a cycling application, it might be a little shorter because you might reach the cycle counter. Now that all of our service life and design life calculations are based on the MTBF failures, which are and now we have 10 years of field experience that we use against that. But there's really no reason that at the end of 20 years the battery would be out of service. If it's it's not going to there's no known degradation over time for this technology. There's no materials consumed or worn. We don't grow many materials on our plates don't change size or dimension. So there's really no end of life per se, other than we have to put something in for commercial terms, right?
Sure. Thank you.
And the other thing too is that if, for example, at 20 years the BMS fails, or you can replace those parts. Like Andrew had mentioned earlier, the batteries are repairable. So
yes, One of the things that our customers have kind of made the decision instead of, at the end of life. Now, we had some of the telecom products have been installed for about 15 years now, or just under 15 years. And so the customers came to us and said, "Hey, should we replace these?" And then our salespeople had to chew their tongues off, right? But from the technical perspective, we really can't recommend that they be replaced because there's no reason that they shouldn't continue to operate.
Yeah, there's a question about marking material. LaMarche can provide that information. We'll work with FZSoNick to get that information for you. Just go ahead and send LaMarche an email at sales@LaMarcheMFG, and we'll grab that information from FZSoNick and get that. And also any inquiries that you may have from your customers, or you would like to go ahead and set up some webinars or lunch and learns using this technology, you can always contact LaMarche again or myself, and we'll go ahead and arrange that with FZSoNick.
One more question about sizing. The typical switchgear load has got a constant draw, and then you have some sort of impact based on the circuit breakers going in, going out, and the recharge of their motors. Is that what you were saying, that you oversize the battery in order to get the instantaneous loads that's required for the circuit breaker?
No, short term duration, we can get quite a bit of energy out of the battery. Like I believe the 125 volt battery has a 150 amp 1 minute discharge rate. So it's just those UPS rates where they're trying to maximize
the 15-second rates and stuff like
exactly.
that.
Right, but they minimize the capacity based on to try and get as much out of it as possible. Where we just don't fit very well in that market. That's where we would have to oversize. But for the switchgear market in general, because of the aging factor, number one, we're generally 20%. We require 20% less than lead just to begin with. Because at the end of life, it's not going to be at 80%. It's still going to be at 100. So we use a 485 methodology for our sizing tools. But most of the aging factor, whether you use the Arrhenius equation or just simple a percentage or a design margin type calculation, in general, our sizing is not an amp hour to amp hour comparison. So and that's why we ask for load profiles when we size it, because in many cases, if you ask me for 150 amp hours of battery, I'm going to say, well, I got 160, 80 amps, a chunk, right? Or 40 amp hour chunks is really what our granularity is. And I could size that, but we're probably going to be slightly oversizing the battery because of the lead acid battery was oversized because of its characteristics.
Just for purposes of finishing that one conversation, and this is just kind of a bottom line general guess, 160 amp hour lead acid battery probably is at the $10,000 range. The NiCad is approaching 2.5 times that. So that's the metric for the crowd with regard to where your cost point might be.
I would say for 160 amp hours, the 125 up 80, you would need 2 of those. You may not need 2 of those depending on the sizing of the lead, but I'm just saying it for simple terms, we would be a little bit probably less for the battery piece of it than the NiCad batteries.
Well, big thing actually on sizing the lead acid that most people kind of gloss over is the temperature correction. If you get down around 40 degrees or so, you're hitting that lead acid battery with upwards of 1.25 to 1.3 multiplier.
Yeah, I would say, I really do think, like if you're looking at a lead acid 160 amp hours, you're not taking into any of like the temperature compensation and things like that. we would be, if we had to put in 2 batteries, we'd maybe be double. So that means we'd be less than the nickel cadmium. But if you start taking into the life of the lead acid battery and at extreme temperatures, and what kind of lead acid, if it's flooded, you know, that needs the maintenance, a spill containment. If it's not flooded, you know, it's VRLA, you know, they still require maintenance and checks for, I mean, I don't know on the 2-volt cells if they require any conductance tests for warranty, but you know, all of that stuff is very, very simple with our batteries. If there's ever an issue, it's, you know, really nothing invalidates the warranty. So
Yeah,
doesn't sound like there's any way to test your battery anyhow for capacity, because the BMS is doing it kind of on an online basis.
mm-hmm.
Yeah, the capacity or gas gauge or capacity figure is always calculated in real time. So you can get it at any time from the battery. And when I tell customers is that this battery is basically binary in operation. You know, you're either going to get it all or you're going to get none. So and so that's why we designed the systems to be modular in approach, because it's very, very easy to put design N+1 redundancy into the systems. So I'd say, you know, for say that 60 amp 160 amp hour solution, even if you lost 50% of the battery, you're probably going to probably be able to still do the most of the load. Probably you might not get 8 hours out of it, you might only get 4. But as opposed to a lead acid battery, when it goes on its knees, you get nothing.
Thank you.
Sounds like you have, looking at your website, more than one warranty option.
Yeah, I would answer that question. And the warranties for our batteries are commercial negotiations. So, you know, if you want a 100-year warranty, Patrick and Cara are just going to price it that way. Since it is a repairable product, we look at the warranty in a completely different manner. It's more like servicing any electronic product now, where you know, we basically have a service depot, right, where when we repair batteries, they go into that depot, and when a customer has a warranty claim, we replace it with one of the batteries that are in the depot. It's very, very simple, you know, operation. We never, you know, if you call us because of batteries in alarm, we'll never ask you what temperature the room was at. We'll never ask you what your conductance readings are. We'll only ask you what the serial number is and when you bought it. Yeah, we actually, give us the serial number, we know when you bought it.
Okay, if there are no more questions.
Michael Myers had a question about how they fit into the solar energy storage arena. We do sell the batteries into energy storage for residential, which is a smaller. We have 24 volt, 48 volt, and then we do have a 620 volt product also for larger battery energy storage systems. So like Andrew had mentioned, they cycle well and they work on float well, and it's all the same technology blade or cell in the batteries. It's just, you know, and the 620 volt has more cells in it and different battery management system. And then on the smaller voltages, it has less cells in it. And then, you know, the battery management system to manage the charge control on those batteries. So.
Yeah, we can share. There's a cycling test being done in Australia. It started out to be a test for lithium batteries, but they've included many other energy storage technologies now. And that test has been running now for well over 2 years, maybe 3 years now. They cycle it basically daily. So it's public. That information is publicly available. We can share that with our marketing information at the website.
Yeah, it's like battery test center I'll have to go look it up, but it's Australia Battery Test Center. And it's pretty interesting to go look at that, because they'll have Powerwall batteries in there and lithium batteries. And then the reports show they may have had to replace units and this and that. And knock on wood, I'm going to knock on this wall here. Ours have been performing very well since we've installed them. So we don't have any of that in our reports about having to replace the batteries or anything of that nature.
I put the link in the chat.
All right, thanks.
Okay. I really appreciate your help here, Andrew, Cara, and Patrick, presenting the FZSoNick sodium battery. Again, if anyone has any interest and wants to go ahead and get a quotation on one, please go ahead and send an email to sales@lamarchemsg.com, and we will go ahead and assist you with that. We will need a load profile, as I mentioned earlier. That will definitely speed up the process. Again, this concludes our presentation portion of the webinar. And we look forward to everyone joining next week. We'll be talking about lithium-ion technology. And appreciate everyone joining again.